Hello friends, today we'll discuss about the dropping eggs problem. So dropping eggs problems means you have a multi-story building and you have some eggs. You need to find the very first floor from where your egg will start broken into. Means you can have multiple story building. Let's say you have third story building. You drop your egg from the first floor, it does not break. Then you is go to the second story, you drop your egg. Let's say it breaks, so it means you need to return the first floor because at the first floor your egg was not broken into. But to get this result you need to do multiple attempt. So you are supposed to give an algorithm which takes the minimum number of attempts. Okay, so this is the problem. Now, so I have divided this problem into two parts. First is how to find the minimum number of attempts, and second is how can you verify your answer that whatever you find is the minimum, and what approach you are supposed to use. Either you can go with the binary search, linear search, whatever you want. Okay, so firstly I'm going to explain the algorithm. With the help of that you will find the minimum number of attempts. For that I have created a table. It is a two-dimensional table. Its columns represent the floors and the rows representing the number of eggs. Okay, so let me fill it. Suppose I have one egg and I need to find the floor from which my egg will start broken into. So for the first floor I will go to the first floor and throw my egg. Okay, so one attempt will be required. In the second story building, I will start from the first floor, then second floor. So first I will try at the first floor, then I will try at the second floor. So the worst case attempt will be 2. Okay, because it happened that my egg does not break at second floor. It can happen. So here we are supposed to give the minimum number of attempts, worst case minimum number of attempts. Okay, let's say I reach at the I need to find at the third story building. So first I will go to the first floor, I will throw my egg, then I will go to the second floor, I will throw my egg, then I will go to the third floor and throw my egg. Okay, so possible attempt will be 3. Similarly for 4 story 4, 5 story 5 and 6 story 6. So these are the worst case scenario. Okay, now if I have 2 eggs, then I need to find the minimum number of attempt. Okay, so let's say for the single story building, if you have 2 eggs, so how many attempts will you require? 1, because 1 egg is extra. Now if you have this 2-story building and if you have 2 eggs, then how many minimum attempts will be required? Let's calculate it with the help of a formula. So as I already explained, for any story building we will start from the first floor. Every time we start from the first floor. So let's start from the first floor. I am at the first floor with 2 eggs. Okay, I throw one egg. If it breaks, so it means I have reached my solution. So this will be the 0. Okay, now if it does not break, so it means I will go up. So now I have how many floors are left? I have used 1 floor, so 1 floor is left because I am trying this for 2-story building. I have tried at the first floor and I throw my egg, it's broken into, so the answer will be 0. Let's say egg does not break. If egg does not break, then I will try for the remaining floors. So remaining floors are 1 floor is remaining. Now I am at floor. So for 1 floor with 2 eggs, now I have 2 eggs remaining and 1 floor is remaining. So 2 eggs and 1 floor means 1. So I will put it here 1. Then I will calculate the maximum of 0 and 1. It will be 1. So it will be 1. Then 1 plus 1 will be 2. What is this one? This one means first attempt. You did whatever attempt you did. This is the first one. So first attempt. So 1 plus 1 equal to 2. Okay. Now I am the second floor. Now I am at the second floor with 2x. Okay. If I drop one egg and if it breaks, if I drop one egg and if it breaks, so it means one floor is remaining with one egg, because egg broken at floor number 2. So you are supposed to find the floor where egg does not broken into. So means you will come to downstairs. So it means you will come at the first floor. So when your egg breaks and you are at the second floor, so means one egg and one floor is remaining. So one egg and one floor. So this represents the floor, this represents the one. So one egg and one floor means one. Put it 1 here. And let's say you throw the egg and it does not breaks. Means at the second floor you find it that the second floor is the only floor where it does not break. Now at the second floor you have 2 eggs. So answer is 0. So 1 plus 1 is equal to 2. And the minimum of this is 2. So put it 2 here. Now come at the second floor. I will explain only for 2. Come at the third floor. So at third floor, let's start from the first floor itself. So first we will try for first, second and third. I am at first floor with 2x. I drop one egg. Let's say it breaks. If it breaks, so this is the result. So I got the result. Let's put it 0 here. Now if it does not break, so I have 2x remaining with 2 floors remaining. So I will check for remaining 2 floors. So 2 floors and 2 remaining x. 2 floors and 2 remaining x. The answer is 2. 2 floors and the 2 remaining x. Okay, so two floors and 2 is will be 2. This will be 2. 2 floors and 2 remaining x. This will be true. 2. Okay. Now I reach at the floor number 2. I throw one egg. If it breaks, so it means I will go downstairs. Then I left one egg with one floor, one egg with one floor. It will be 1. Okay. If it does not break, so it means remaining third floor is left. So one egg, 2 floor. So 2 floor and one egg. This will be 1. Okay, fine. Now again I throw one egg. Now I reach at the third floor and I throw one egg. So 1 plus, if egg breaks, so it means 2 floor is left. I need to go downstairs. 2 floor is left and 2 eggs is left. It means 2 by 2. 2 by 2 means 2. If nothing breaks, if egg does not break, so it means we got the answer. So 1 plus 2 is equal to 3. Okay. 1 plus max of 1 is 1. So 1 plus 1 is equal to 2. And 1 plus 2 is equal to 3. So what is the minimum? Minimum is 2. So we will put the minimum here. So let me explain once more. If we are at the fourth floor, so again we will start from the first, second, third and fourth. So I am at the first floor with 2x. I throw the x. If it is broken down, so it means I got the answer. If it does not broken down, so means I have 2x and remaining 3 floors are left. So 3 floors and 2x mean 2. Now I am at the second floor. I break one egg. If it broken down, so means one floor and one egg is remains. Okay. So 1 comma 1 means 1. If it does not break, so it means 2 floors is left and 2x are left. So 2 floors and 2x. 2 floors 2x means 2. Okay. Now at the third floor, I throw the one egg. If it breaks down, so means 2 floors are left and 1 egg is left. So 2 floors and 1 two floors and 1 egg. Okay, 2 floors and 1 egg means 2. 2 floors and 1 egg means 2. Okay, if egg does not break, so means 2x and 1 floor. 2x and 1 floor means 1. Now I am at the fourth floor. If I break the eggs, if it breaks down, so means 1 egg is remaining, 1 has already broken and 3 floors are remaining. So 3 floors 1 egg means 3. If it does not break, so means I got the answer. So 1 plus max of 0 2 is 2 3, 1 plus max of 1 and 2 3, 1 plus max of 2 and 3, 1 plus max of 3 0 4. So minimum is 3. Similarly, I calculate for 5th and 6th floor. So the answer is 3. This is the answer. So whatever comes into the column 6 is the answer. Now, what is the formula to calculate this? The formula is, let's say I have an H-story building, okay, and I have EX. So formula is f of H is equal to K start from 0 to H minus 1. So K is every time K start from the first floor 0 to H minus 1, max of f H minus K E. It means if you throw your X, okay, if it does not break, let's say this, let consider this first. You throw your egg, if it breaks, it means you need to reduce 1 floor. You need to go down 1 floor and you need to reduce 1 egg. Your egg has already broken into. So now you will check the remaining K minus 1 floor with 1 egg less. Okay. Other thing, if egg does not breaks, so what are the floors are remaining? H minus K. Let's say in a 3-story building, in a 4-story building, you are at the second floor, right? With 2x. So if your egg breaks, so you will come down. So means floor, the K is equal to 2 here. So if your eggs break, your K will be 1 now and egg will be 1 now. So this is the function. If your K is equal to 2 are at the second floor and eggs breaks, so you will come down. So K minus 1 and E minus 1. You will reduce 1 floor and you will reduce 1 egg. Let's say if egg does not break at K is equal to 2, then the remaining floors are 4 and 3. So you will reduce the second floor from the total number of floors and you will check with your X with the remaining floors. So the H minus K are the remaining floors. K is that second floor, so H minus K means 4 minus 2 will be 2 and 2x. Okay, so we'll calculate the max of these two. Plus 1. Plus 1 means whatever you throw. So you count the 1 attempt when you throw the egg. Since you are traversing each floor n times, so for each different floor, the complexity will be n into n. And you are doing this kind of calculation for all of x, so the complexity will be n into e. So the complexity will be order of e into n square. Now let's verify. So here I am using a binary search to verify our result. So let's say I have an H-story building and I have divided this building into the multiple block of size x. Okay, so how many blocks will be h by x? So let's say in the worst case I start throwing x from here. First I will start throw x from the first block. If it breaks down, I will go down. If it does not break, I will go up. I will go to the next block. Okay, so let's say I try everything and I have reached the n minus last blocks and my egg does not breaks. So I have tried all h by x attempt. Okay, now I need to go from this x value to h at the last block. So I will check all possible combination, or I will check all the floors. Okay, I will check all the floors between h and x. Let's say this is a 100-story building and I have divided into x is equal to 25. Okay, so first I will check for 25. It does not break, I will go 50. If it does not break, I will go 75. When I reach the 75, I will check from 76, 77, 78, 79 and 100. Okay, so how many computation will be h by x plus x? So these many computation will be there. Now this is a function of x. Okay, we need to find the point at which the minimum value at which this function will be minimum. So we need to calculate the minima and maxima. So to calculate the minima and maxima, we need to differentiate this function with the help of x. So when we do the differentiation, it looks like minus h by x square plus 1 is equal to 0. Then it changes to x square is equal to h, means x is equal to root h. So it means if you take the block size of square root of your building, then you will get the minimum number of computation. Let's say your 100-story building is there, so block size should be 10. So if you get the block size as 10, the number of computation will be minimum. Now check if this is a point of minima. We would need to do again differentiation, d square by dx. This will be h x square plus 1 2h by x cube and 2 by h cube. Now put the value of x here. So this will be h root h. Okay, 2 by root h will be positive. So to x to be a minimum point, this should be a positive value. So this is a positive value. It means x is equal to root h is a positive is a minimum point. So to get the minimum number of computation in the binary search, the block size is be root h. Now let's verify with our computation. In our case, h is equal to 6. Okay, in our case h was 6. Take the root of it. So x is equal to root 6 is equal to 3. So if I break this 6-story building in a block of size 3, then the minimum number of computation, let's say I throw my x from here. If it breaks down, then I will come down. I will try at 2. Then I will try at 3. So minimum number of computation are 3. Now let's say it does not break. Then I go up. I will try at 4. Then I will try at 5. So the minimum number of computation are 3, because we will not try at 6, because that is the top floor. So we verify our approach, whatever we did, and we verify the result with the help of binary search and minima and maxima. So thanks for watching.